We'll proceed in multivariable calculus. We are in phase of calculating. We are in phase of calculating the mind-blowing surface area. Okay, there are two approaches in calculating the surface area. What are two approaches? One is called conventional approach. Conventional approach means whatever is available in the book. That is typically called conventional approach. Thank you very much for your conventional approach. What is non-conventional approach? Our pseudo multivariate calculus. Pseudo multivariate calculus means that we start solving a problem through normal mathematics. Whatever mathematics we know, through that we start solving the problem, and later we feel that we can use calculus or vector. We may not feel the need to use the calculus and vector. That is up to us. Okay. But in conventional way, we start with the calculus only, like calculation of the surface area. Like the calculation of the surface area. If this is the surface area, if this is the surface area, how to calculate the surface area? Okay, that is one thing. There is another thing called surface area vector. There is another thing called surface area vector. One is called surface area and one is called surface area vector. This is for sure that everyone understands that if I have a vector and if I calculate magnitude of the vector, then I get the, if I have a vector, then if I calculate the magnitude of the vector, then I get the net content in the vector. Whereas if I have a vector, if I divide the vector by magnitude, then I get the unit vector. So vector is nothing but an energy which has a direction and which has a magnitude. Magnitude is called power of the vector, energy, and direction in which direction it is moving. So if I am calculating the area of a sphere, then first I need to calculate the area vector of a sphere. If I get area vector of a sphere, if I calculate area vector of a sphere, then area vector can be used in many other calculations. One of them is flux calculation. Flux calculation, calculating the area vector through flux calculation, calculating the area vector through flux calculation means velocity vector dot product with the area vector. If I have velocity vector dot product with the area vector gives the flux vector. We gives the flux calculation. Velocity vector dot product with the area vector gives the net flux. Dot product of two vectors, it resolves in numerical component, non-vector component. Okay, that is one use of area vector. Other use of area vector is area vector. If someone has area vector dot product with the height vector gives the volume. If someone has area vector dot product with the height vector gives the volume. Okay, I believe it is all right. Area vector has many uses. Area vector, magnitude of the area vector gives the net area. If I'm successful in calculating the area vector of this sphere, then calculating the magnitude of that area vector will give the surface area of the sphere. Or if I have area vector dot product with the velocity vector give the net flux. Flux is amount of the liquid volume per second coming out of the surface. If there is a velocity of fluid is going with a velocity, fluid is passing through a velocity, it is hitting a surface, then how much is the volume per second coming out of the surface? Surface area vector dot product with the velocity of the fluid. If surface area vector is perpendicular to the surface. If this is the surface area vector will be perpendicular to the surface. If this is the surface, the surface area vector will be perpendicular to the surface. Okay, it depends upon the orientation, in what orientation it is. So this follows this kind of rule. If surface orientation is like this, then this is the area vector. If it is like this, that will come as anti-clockwise. This is anti-clockwise, then this is the surface area vector. So if I'm talking like this, then it should be anti-clockwise to have like this, whatever it is. If this is the surface and this is up, if this if this is the if this is the surface and this is the area vector and velocity is passing like going like this, then they are in parallel to each other. Theta is 0 degree. If that is the case, then velocity into this area is the flux. But if this is the velocity, if consider this is x-axis, this is y-axis, this is z-axis. If that is the case, consider the velocity of a liquid is passing like this, and this surface is like this, sometime like this, sometime like this, sometime like this, sometime like this. But velocity is always in x direction. Now it makes angle now. Then velocity vector dot product with the surface area vector. If it is like this, then surface area vector is like this. This is the surface area vector perpendicular to this. Surface area vector will move like this, like this. Okay, surface area vector has innumerous uses. Surface area vector dot product with the height vector gives the net volume. It has innumerous uses. How to calculate surface area vector is through modern way. If if consider this is centered at the origin, consider this is centered at the origin. If this is centered at the origin, then half of the hemisphere is above the xy plane. If this is xy plane will cut this sphere at the center. Half of it is above the xy plane and half of it is below the xy plane. This will cut it at the center. If that is the case, then consider any point P here from the origin. If it is centered at the origin, exactly at the center of this is 0, 0, 0. From the origin, if this consider this point is P. Okay, this P is x comma y comma z. From this origin, if I draw a vector like this, then that is called position vector. But that position vector represents the surface area. Okay, position vector can represent a line also. If I have a line, consider this is a line. On this line, this is point P, and this is x comma y comma z again, and this is center. From center, if I draw a vector, then it is passing the point x comma y comma z. Okay, if that is the case, then position vector is xi plus yj plus zk. But this position vector is represents a point on a line. If I have a point on the surface P from origin, if position vector passes the P, then position vector represent a point P, that is x comma y comma z on a surface. This position vector represent a surface vector. Surface vector means position vector it represent a surface. D of position vector is another vector. D means derivative. Derivative of position vector is another vector. Okay, in that sense, what is that vector? If this is a position vector, if this is a line, consider this is a line, and this is point P. From origin, if I draw a position vector, if I calculate derivative of this position vector, then another vector will come that will be tangential to this at point P, tangential to the line. If line is straight, then derivative of position vector will be a vector that represents the line, because tangential to the line is another vector that is parallel to the line. But if it is a curved line and this is point P and this is position vector, then the derivative of position vector at this point, it will be tangent at this point. Everywhere it will be tangent. Okay, if this is the if this is the curve, and considering this is origin and this is position vector at this point, at this point, at this point, then derivative of position vector will be along the line. Okay, that is the derivative. If I consider position vector for a surface area, calculating this is position vector, from inside it will come out. derivative of position vector will be along the surface. Means derivative of a position vector that represents an area is area vector. That's it. So d of p is area vector. D of p is area vector. If d of p is area vector, then what is p? P is xi plus yj plus zk. D of p means dxi plus dyj plus dyk is the area vector. Was it that is area vector is dxi plus dyj plus dzk? That is, if position vector represent a line, then tangential vector is again dxi plus dyj plus dzk. Then what is difference between this area vector and position vector and tangential vector? Both are dxi plus dyj plus dzk. This is called abstract vector. This is not the actual one. Actual one we have to derive. So for actual one, but this is the abstract, we have moved one step forward, that is d of position vector is the area vector, whereas p is position vector. If d of position vector is area vector, then d of p is same as d means small d, and capital P on top of it arrow mark, d of position vector. D of position vector by dxy plane into dxy plane. Same thing. D of position vector equal to D of position vector by D of xy plane into D of xy plane. Now this talks about, consider this is xy plane. These things we have already demonstrated. Consider this is xy plane. Hop, hop, hop. If this is xy plane and this is the surface, consider this is centered at the origin. If this is centered at the origin, half of it will be above and half of it will be below. And center of this will be coincide this origin point, that is blue point, origin point. Now it will be like that. Someone can imagine. Now, if that is the case, then d of position vector by d of xy plane. Xy plane is the area on the xy plane, and d of position vector is the area on this surface. Okay, d of xy plane. If I make one unit of area change on xy plane, how many unit of area change I see in the on the surface? dp by dxy plane. I'm not talking about dz by dxy plane. If I said dz by dxy plane, if I make one unit of area change on xy plane, how many unit z will change? But that is not talking about the area in the numerator. dp, p talks about x, y, z all together, means that is the surface point. dp by dxy plane means if I make one unit of area change on xy position vector, if there is a position vector p here, that is x comma y comma z, then from here if I draw a vertical line, from here if I draw a vertical line, it will go and it will hit the xy plane somewhere. Okay, that point is x comma y and this height is z. Okay, that is p at x comma y on xy plane. If I make one unit of area change, then correspondingly one unit. If there is a x comma y on xy plane, then x comma y, if I draw vertical, then vertical will go and it will hit some point here. That is p. Similarly, from x comma y, if I make one unit of area change, then there will be one unit area. One unit of area change, one unit of area if I draw from x comma y on xy plane. These are very intricate and not available in any of the book. If this, consider this point is x comma y. From here, if I make a small area, this is origin. From origin, this point is x comma y. From here, if I make one unit of area change, then that area, if I bring up, it will hit a surface area on this surface also. A point, a point on xy plane will go hit here another point on the surface. That point is x comma y comma z. If I make an area on the xy plane, area will have infinite point. All infinite point will go up and it will hit infinite point here also. If I connect all point here, it will make a surface. If I make one unit of area change from point x at point x comma y, or around x comma y, also someone can think, whatever it is. People know derivative concept, differentiation concept. Then how many unit area I change, surface area I see on the surface, that is dp by dxy plane. In order to calculate that, we took delta x and delta y in xy plane, and accordingly we saw if I from x comma y, from x comma y point, if I move delta x from x comma y point, from x comma y point, if I move delta x along x axis, and if I move delta y along y axis, I have 4 points. One point is x comma y, one point is x plus delta x comma y, one point is x comma y plus delta y, and one point is x plus delta x comma y plus delta y. These 4 points, if I move up, it will map another 4 points here. Original point is P, that is x comma y comma z, or x comma y comma fxy. Another point is P1, that corresponds to x plus delta x comma y function over x plus delta x comma y. Another point is P2, that is x comma y plus delta y comma function over x comma y plus delta y. Okay, if I take these two lines, one is P, that is the original point x comma y comma z, P1, that is x plus delta x comma y comma f function over x plus delta x comma y, and P2, that is x comma y plus delta y comma function over x comma y plus delta y. These two are vector now. P1 P vector, P2 P vector. If I make cross product of these two vectors, P1 P vector and P2 P vector, then it will give the surface area that is formed on this surface, divided by the delta x delta y what we have taken, that is exactly dp by dxy plane. Please watch our previous video. We have calculated it, and it comes as dp by dx cross dp by dy into dxy plane, that is delta x delta y dx dy. Is it the surface area vector? Certainly. This is the surface area vector. dp by dx cross dp by dy bracket close into dx dy. This is the surface area vector. Anyway, then we saw this is the first idea. Second idea is, can we go with the, this is Cartesian coordinate system, can we go with the spherical coordinate system? In a spherical coordinate system, position vector is xi plus ya plus zk. X will be replaced by g theta phi. X will be replaced by function with g theta phi. R is constant for a surface area. Y will be replaced by h. H is a function theta r phi, and z will be replaced by a function that will be function, z is function over x and y. Z is dependent component in xy plane. Z equal to function. Actually, in the past video, we had talked about the spherical coordinate system. I will complete it. Okay, it is very complex, so I am going step by step. Now, if that is the case, what is x? X is r sine phi cos theta. If anyone see the spherical coordinate system, x is r sine phi cos theta, y is r sine phi sine theta, z is r cos phi. Okay, but if I see in Cartesian coordinate system, x is independent, y is independent, and z is function over x and y. If I say Cartesian and a spherical coordinate system, x is function. X is function over theta and phi, considering r is constant. For a surface area, radius is constant. So x is function over theta and phi. Y is function over theta and phi, whereas z is function over x and y. So I say x equal to g is a function, g theta comma phi. Y is a function, y equal to h theta comma phi, where z equal to f. F is a function over x and y. F bracket g theta comma phi comma h theta comma phi. Makes sense? So this is the global picture. If that is the case, then how we can get the area vector in spherical coordinate system? For a spherical coordinate system, again, the area vector is d of position vector only. Now, d of p equal to d of p by d of theta phi into d of theta phi. Make sense? D of p equal to d of p by d of theta phi into d of theta phi. If that is the case, then what is dp by d theta phi? In theta phi plane, if I make 1 unit of area change, how many unit of area change I see in position vector? Now, last video, we saw that there is xy plane, and accordingly, there is a theta phi plane. On xy plane, I have this surface area. On xy plane, I have this surface area. There are three entities now. This is a surface area which has a point P, and actually this sphere is centered at the origin, and half of it is above the xy plane and half of it is below the xy plane. In that case, there are three things. One is theta phi plane. Another is xy plane, and above the xy plane we have a surface where position vector p is there. Earlier we computed dp by dxy plane, so surface and xy was here. Now I am calculating dp by d theta phi plane. Hope. This is position vector dp, and this is xy, and there is another called theta phi plane. Actually we have three entities now. One is called theta phi plane and one is called xy plane. Above the xy plane, we have the surface point P. Now, if I make 1 unit of area change in theta phi plane, then how many unit area change I see on the surface where position vector P is there? Now it is actually complex. This explanation is not available in any of the book. Please mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Anyway, this is theta phi plane and this is xy plane. Above the xy plane, I have the surface where point P is there. If earlier, if this is xy plane, if I make 1 unit of area change, then how many unit of area change I see on the surface? dp by dxy. Now we have dp by d theta phi into d theta phi. If I make 1 unit of area change on theta phi, then then how much area change I see on the surface, position vector on the surface. XY plane comes as a mediator now. Now in XY plane, I have X and Y. Okay, X is function over theta and phi. Y is a function over theta and phi. Makes sense? X equal to R sine phi cos theta. Y equal to R sine phi sine theta. Okay, in that sense, XY plane and theta phi plane, this is how they are related to each other. If I talk about theta phi plane here, and this is xy plane, consider this point is theta comma phi. If from this point I move along, this is theta axis, x axis is theta axis, another vertical axis is phi axis. From the theta comma phi, I move theta plus delta theta comma phi, and from theta comma phi, I move theta comma phi plus delta phi. If that is the case, for theta comma phi, I have a mapped point called x comma y, where x equal to g theta comma phi, function over theta comma phi. So x comma y is h theta comma phi. Now, if I have 3 points here, one point is theta comma phi, one point is theta plus delta theta comma phi, and one point is theta comma phi plus delta phi. Similarly, for that we will have 3 points here also. One is g theta comma phi comma h theta comma phi. Another point is g theta comma phi, g theta comma phi, g theta, there is a point called theta comma phi. Another point is theta plus delta theta comma phi. We come back to the original point, and in vertical direction we have theta comma phi plus delta phi. For theta comma phi, we have a mapped point called x comma y, or g theta comma phi, h theta comma phi. Then there are 3 points here, correspondingly 3 points here also will be there. One is g theta comma phi, h theta comma phi. Another will be g theta plus delta theta comma phi, h theta plus delta theta comma phi. We'll come back to this position. And another point here will be g theta comma phi plus delta phi, comma h theta comma phi plus delta phi. Now we have 3 points, one point, this point, and this point. Now this is xy plane, and this is the surface called point position, point P. Now P correspond to x comma y. P correspond to x comma y comma fxy. Function over x and y, that is z. P point is x comma y comma z. That is x is g, x is x, y is y, and z is fxy. If x is, or in a spherical coordinate system, it is g theta comma phi comma h theta comma phi comma function over g theta comma phi comma h theta comma phi. Now if there are 3 points in xy plane, it will go and map 3 points on the surface also in similar fashion. One point P is the original point, that is x comma y comma z. That is g comma theta comma phi comma h theta comma phi, g theta comma phi comma h theta comma phi comma f function over g theta comma phi comma h theta comma phi, that is z. This is point P. There will be another called point P1. P1, that is g theta plus delta theta comma phi comma h theta plus delta theta comma phi comma f function over g theta plus delta theta comma phi comma h theta plus delta theta comma phi. This is point P1. Actually, in theta phi plane, there are 3 points. One is theta comma phi, one is delta theta plus delta theta comma phi, and one is theta comma phi plus delta phi. Correspondingly, there are 3 points on xy plane. Correspondingly, there are 3 points on the surface. One point is P, that is x comma y comma z. One point is P1 and one point is P2. P1 is g theta plus delta theta comma phi comma h theta plus delta theta comma phi comma function over g theta plus delta theta comma phi comma h theta plus delta theta comma phi. That is P1. P2. P2 is g theta comma phi plus delta phi comma g theta comma phi plus delta phi comma h theta comma phi plus delta phi comma function f over g theta comma phi plus delta phi comma h theta comma phi plus delta phi. Now, if I have made a delta theta delta phi change here, accordingly there will be change of delta x and delta y here. Accordingly, there is a change on the surface, that is P1P cross P2P. Makes sense? Now, if that is the case, then what is dP by d theta phi into d theta phi? If I make 1 unit of change, area change in the theta phi plane, then how many unit of area change, how many of unit area change I see on the surface position vector? If that is the case, but I have made delta theta delta phi change in theta phi plane. So whatever change I see in surface area divided by delta phi delta theta will be the actual dP by d theta phi. dP by d theta phi I replace with delta theta into delta phi. That is the change I brought in here in theta phi plane. In the surface area, P1P cross P2P. P1P is g theta plus delta theta comma phi minus g theta comma phi I plus h theta plus delta theta comma phi minus h theta comma phi j. This is P1P vector plus function over g theta plus delta theta comma phi comma h theta plus delta theta comma phi minus function over g theta comma phi comma h theta comma phi. This is P1P vector cross product with P2P vector. P2P vector is g theta comma phi plus delta phi minus, I'm sorry, g theta comma phi plus delta phi minus g theta phi I vector plus h theta comma phi plus delta phi minus h theta comma phi plus delta phi j vector plus function over g theta plus delta g theta comma phi plus delta phi minus g theta comma phi, okay, comma h theta comma phi plus delta phi. I'm sorry, the third component is function over g theta comma phi plus delta phi comma h theta comma phi plus delta phi function over minus function over g theta comma phi comma h theta comma phi. This k, this is p2 p vector. Now p1 p vector cross p2 p vector, that is the d of p that we are saying, divided by delta theta delta phi. Delta theta I can keep one side of the cross product and delta phi I can keep on other side. Now first side, if I settle it down, that is p1 p vector, then it will resolve in g theta plus delta theta comma phi minus g theta comma delta theta comma phi I g by delta theta, g theta plus delta theta comma phi minus g theta comma phi by delta theta is g d of g by d theta, d of g I vector, g is x, means dx by d theta I plus dx plus d of h by d theta, d of y by d theta plus, that is the main thing. There we are getting function over h theta plus delta theta comma phi min comma phi comma, I'm sorry, function over g theta plus delta theta comma phi minus g theta plus delta, I'm sorry, again, function over g theta plus delta theta comma phi comma h theta plus delta theta comma phi minus g theta comma phi comma h theta comma phi. I'll rephrase it again. The third component of p1p is function over g theta plus delta theta comma phi min comma phi comma h theta plus delta theta comma phi, okay, function close, minus function over g theta comma phi comma s theta comma phi function over divided by delta theta. It is exact case of d of function over g comma h divided by d theta, that is nothing but dz by d theta. So p1 p vector divided by delta theta resolve into dx by d theta I plus dy by d theta j plus dz by d theta k cross product. Now we have p2 p vector divided by delta phi. p2 p vector is g of theta comma phi plus delta phi minus g of theta comma phi I by delta phi, that is same as dg by delta phi, dx by delta phi. Now if I go along, it will become dx by d phi I plus dy by d phi j plus dz by d phi k. All along it becomes dx by d theta I plus dy by d theta j plus dz by d theta k. It is dp by d theta, means d of xi plus yj plus zk by d theta, dp by d theta cross dp by d phi, means dp by d theta phi plane is dp by d theta cross dp by d phi into d theta phi. Now this is the position vector. This is what we deduced yesterday. I went through some assumption. Anyway, no need to go for assumption, and this is the actual proof of the area vector in a spherical coordinate system. But this is called hybrid spherical coordinate system. This is not the exact spherical coordinate system, because x, if I see the position vector, it is r sine phi cos theta I. I is Cartesian coordinate system where r theta phi is spherical, plus r sine phi cos theta j, where one part is spherical and one j is Cartesian, and r cos phi k is Cartesian and r cos phi is spherical. It is not the full spherical coordinate system. What is full spherical coordinate system? Position vector, what will be area vector in full coordinate system? Again, it will be same thing, d of position vector. D of position vector equal to d of position vector by d theta phi into d theta phi. But d of position vector will be different. Earlier d of position vector was d of xi plus yj plus zk. But this is Cartesian coordinate system. Then we transform into a spherical, but ijk was there. What is pure spherical coordinate system in r vector, k vector, and phi vector? That we will talk. And then we will see that if everything is same, okay, then we will see through the our pseudo multivariate calculus also. Mind blowing, head storming, wall hitting. Anyway, please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.